So what we see that we have to do here is there's a start here file, which is the same thing that's on the front page news. And then a homework assignment. This is actually a link to the Dropbox. And then a quiz. The quiz is just a, have you ever taken another programming course? If you ever used a programming language at work? And please send me a text. The text is so that I can communicate with you. Last spring, we had a brutal, in terms of missing school, brutal series of ice days that we lost. So the once a week courses lost like 3 weeks worth of work just because of ice days. But if we're going to have heavy storms, tornadoes, ice, stuff like that, it's really useful for you to be able to check with me, and I'd be able to check with you to make sure you're not going to show up or something like that. And although this is like the last question of the quiz, if you would go ahead and be so kind as to text me at 898-7767. Just send your name and the fact that you're in scripting. And I'll only use that to contact you about school-related matters, related to this class, specifically if I know class is going to be canceled. You, however, can contact me as often as you want. If you're stuck on a programming problem, just take a picture of the screen, text it to me, and I'll go, oh, well, you left off the semicolon there, or whatever. So, text, a lot of students find it a really good way to get a hold of me. If you don't like texting, of course, email's cool. Call me, same number. It's all good. Alrighty, so what is this class? This is script programming. What we're going to be doing is learning to use Python and JavaScript. Python for writing interactive programs, and JavaScript to show you how to enable parts of a web page to be interactive. And there's some similarity between them, but not a whole lot, except as much as every programming language has similar constructs, and that they can have variables and do math and do loops and stuff like that. So that's what we will be learning. The first, a little more than half will probably be Python, and then the last half, or a little bit less, will be using JavaScript. So you'll see a little bit of HTML. This isn't an HTML course, but you just have to have HTML because that's what JavaScript hangs off of. HTML is the tree, and JavaScript is all the, the tree house and the swing tires and the ladders and stuff like that that make that tree much more interesting. So my name's Jeff Thompson. I don't care what you call me. Mr. Thompson, Professor Thompson, Jeff, I'm not picky. My office is right downstairs in 102, and my office hours are posted in D2L, which, if you logged into our D2L section, you've already seen. I don't have evening hours posted, but that doesn't mean that I'm not available in the evening. Okay, I do have evening hours available on a Monday. I can be here on evenings if you need me, Tuesday, Wednesday, or Thursday. I can also be here on Friday if you need to meet. Just set up an appointment and I'll come in. So, yeah. I try to make myself available. On the other hand, a lot of people just communicate, through text and email. They don't need to do face-to-face stuff. But if you get stuck on something, and if you have a programming language on your laptop, come and bring your laptop to my office, or whatever. We can work side by side and we'll get it done. So there's a prereq for this course. It's assuming you've had CIT1203, which is, Introduction to Programming. Now, Introduction to Programming here was kind of an interesting deal in as much as different teachers were teaching different curricula entirely. Some were teaching Python, some were not teaching Python. And the standard is that all classes of CIT1203 will be taught with Python in the future. So the instructors who were not doing so in the past will be doing so now. However, that means that some of y'all do not already have Python experience, and some of y'all have already had a semester's worth of Python. So the good news for the students who have not already had Python is that I do not assume that you have had it. The good news for the students who have had it is that there's going to be some review, and it's going to drill it into your brain even more, but there's also going to be new stuff as well. But it is assuming that you know programming logic. You've seen if statements, and you've seen variables and numbers and expressions with multiplies and equal signs and less than signs, and loops and that kind of stuff. If you've never had any programming whatsoever, then you'll still be able to do okay in the course, but you may have to work harder. The book is an awfully good book at introducing programming. So we have a good textbook, unlike the 1113, where we had a really pretty bad textbook.
That's an understatement.
So there's the name of the class. It's a hybrid course. We meet once a week, meaning that we need to make the best use of our class time, and that you're going to be expected to do a little bit more homework than you did the last time, since those who had my class 1113, we did a lot of work in class, and so thereby we did not do quite as much homework. Typically what will happen is if there's an in-class assignment for that week, there'll also be a homework assignment that goes hand in hand linked with it. But there may be some weeks where we don't get to do an in-class assignment because we lecture too much. We being that guy up here who's referring to himself in the plural for some reason. Alrighty, so if you're going to install Python at home, that's a good idea because you could do your homework at home. Home, makes sense. But also all the computers in this building, all the classroom computers, as far as I know, do have Python installed on it, including the lab over there. So if you do not want to install anything on your computer at home, you can get away with coming to campus and doing it. However, it's nice to be able to, wake up at 2 in the morning and, like so many of us do, want to do Python programming then. So that will be part of the first assignment, is that I want you to either install Python or at least tell me that you're going to come and do it on campus. I want you to make that decision known to me. So here's a textbook. They magically changed it between semesters, they being the publishers. So, publishers do that just to soak up the supply of used textbooks. So every so often they'll come out with a new version, and it really will be no different. But hopefully you've got this version of the book. For some reason, the Roast bookstore did not have it. I do not know if that has been corrected. But Ratcliffe's has it, Amazon has it, other online bookstores have it. I'm not going to require you to read from the book this week, but it sure would be a good idea to get it and to start reading the first chapter. Hopefully, you can stay a little bit ahead of the lecture by reading in the book, and I'll let you know what we're going to lecture about next week, so that when I'm up here talking, it's not the very first time you've ever seen the idea. So what are we going to do? We're going to learn scripting with the Python language. We're going to understand such things as arrays, lists, dictionaries, parameter passing, and class creation, which is part of object-oriented programming. Input and output file handling procedures, and use JavaScript to create dynamic web pages. What is a dynamic web page? Dynamic web page is one that changes as you click around on it. Here's a web page. Things light up as I move my cursor over. There's menus. Did you see that? When I clicked on that, we saw a little spinning wheel, and then it popped a menu up. It was gathering a list of things that could be chosen from there. Back when the internet and the World Wide Web first came to people's consciousness, there was no JavaScript, and web pages were not very interactive. Let's see if we can find a really old web page. Here's one. Okay, that's pretty cool. All it is a text and a series of links. Very quickly HTML was expanded to have, fields that you could fill in and submit. But this is a far cry from the way the internet looks today. And what's happened is that JavaScript allows the customization of the web page once it has been downloaded to your browser. There's two places that the web page can be altered. One is beforehand, before it's sent to your browser. There's a program on the server that goes ahead and creates that web page and sends it to you. And the web page could just be a file, or it might be constructed on the fly by some software on the server and it's sent to you, and your browser has to interpret it and display it. So this one is probably just a straight file. And if we did view page source, we see some HTML there, but Nothing fancy is going on there. But with JavaScript, everything you see, every sentence, every link, every picture is a component that can be modified via script. You can hide things, you can insert new things, things can change as you mouse over them. So the idea is to make the web much more engaging. And we just pretty much consider that as a matter of course anymore. If you went to a website nowadays that looked like that, you'd think, oh, whoa, that's really pretty lame. So, you go to Amazon or whatever, and it's, super interactive. All these light-up boxes and stuff like that to try to make it as easy to use as possible. And D2L has grown a lot in the past decade. It's a lot more sophisticated than it used to be. With the editor that'll pop up, that's all pretty much done with JavaScript. So we will have multiple assignments. We may have occasional chapter quizzes. I'll give you advance notice of them, or I'll just upload them and let you do them, as homework. And 2 exams. So where to start? Go to Brightspace, go to D2L. Well, it's called Brightspace. It used to just be called D2L. They changed their company name to Brightspace, but we haven't changed our URL to bs.rose.edu, so it's probably going to stay D2L. And then take Quiz 0. By you being here today, you're proving that you're attending the course, but also by taking that quiz, you prove that you're participating in the course, and that way you cannot get dropped with an AW, which is what happens if you do not show up the first week or the first 2 weeks of a course. Obviously, all of y'all are here, but never take a military or government loan for a course and then do not attend, or else the government comes back for their money from you. So, here's your email. If you have trouble accessing email, there's a phone number for IT. If you get stuck accessing D2L, you can log on to d2lsupport.rose.edu, type in a question, and say you'd like a response by phone, and they get back with you really quickly. Okay, so the grades. I actually meant to change this so that it was 33%, 33%, and 34%, rather than having a separate section called quizzes. So tutorials are in-class assignments. When I have something that I want to teach you and that I want to see you type in hands-on so that I know that you're learning it in here, that's an in-class assignment. And then there's programming homework. Programming homework could be based on the book, or they can be something that I write up. It's fair game for me to say, please do, problems 3 and 4 from the book. More often I come up with my own assignments because I think my own assignments are more interesting than the book assignments. But working from the book is also a good thing. And then the exams, a midterm and a final. So forgive me for, I will update this and re-upload it. A third of the class is based on the in-class. A third of the class is based on the programming homework and quizzes. And then 2 exams. Grade scale is pretty traditional. 90 and above's an A, 80 and above's a B, 70 and above's a C, and so on. Spring break, we get a spring break. Last day to withdraw is in April. However, if you want a refund, full refund, you better withdraw really quickly. I don't even know when that date is. Hopefully we haven't passed it, but hopefully none of y'all want to withdraw. And then our exam is on. It's not going to be on Tuesday. This is a Monday. Our exam's going to be Monday at its normal time, and if that conflicts with another course that you're taking, just let me know. And this sentence needs to be revised because it's assuming that you're taking the exams at home. I apologize for not having modified this sufficiently for the in-class. Exams, unless said otherwise, will be in-class exams. There's a possibility that if we don't want to take a class period in order to do an exam, because with only 15 class periods, taking one away to do an exam is kind of a drag, then we might do the midterm as a home exam. But probably do it in here.
Will they be similar to your intro programming class?
Right. The exam is a mix of multiple choice and a couple of fill-in-the-blank type lines and a little bit of writing some code. So programming assignments must be able to run in order to receive any credit. Python's kind of picky. It tries to compile your code before it runs it, and if it finds obvious mistakes, it just won't run at all. It's not nearly as picky as other programming languages, except about indentation. But your program has to be able to load for me to give you any credit. If you don't, you're just going to get like 2 points out of 100 for the assignment. And the reason I give you 2 is so that when we're looking at your list of grades, those just immediately jump out. Whoops, that one didn't compile. So does that mean you failed the assignment? No, it means that I want you to fix it and upload it again. People were talking, the administrators of D2L were here in the division today, talking about some of the tricks that people do to try to get additional time on their assignments, like loading a corrupt document that can't be opened, and then secretly they're going in there, and then when the instructor says I can't open it, they go, well, I know it worked, and then they give you the good version of it. Don't do that. Just give me what you have, and then if it does not work, I want you to correct it and upload it. And if you do that, you'll get more credit. You'll probably get full credit for it. Any time that I assign partial credit for an assignment because it's missing functionality, like if I wanted to do 3 different things and you only made it 2 different things, I'll give you partial credit for it, but you are then free to fix it and get more credit. And the reason for that is I'd rather you learn the entirety of the assignment, and you'd like to make a good grade. So, we can work together on that. If you receive only partial credit due to either a program having syntax errors, because it could be that right before you uploaded it, you accidentally put your, elbow on the keyboard and messed it up, or whatever. Fix it, resubmit it, it'll run then, you'll get some credit. If it does not run, my assumption is that you didn't understand it and you didn't care enough to get it to work. Because if you can't get it to run and you're not communicating with me, you're not taking pictures of your code and sending it to me in text or whatever, and we're not fixing the syntax errors or you're not emailing me about it, then I'm just assuming that you typed in some stuff, you didn't care if it ran and you gave it to me. And if you don't care if it runs or not, I don't care if you get a good grade or not. But I do care if you get a good grade because I want everybody in here to learn it. I want you all to learn the material and make good grades. I'm very happy when everybody in the class makes an A or a B. That's my goal. Plagiarized assignments. Whoops, I skipped one. This says programming assignments are due 1 week from the day they are assigned. Well, they're due when they're due. Every time I upload an assignment, I will put a due date in it. But that's covered on the unless otherwise specified clause. And the reason for that is if I give you an assignment and the next week is spring break, I'm not going to expect you to turn in something on Monday of spring break. I want you to fly down to Mexico or whatever, or do whatever people do on spring break now. Probably just, stay home and do more housework, I don't know. So anyways, homework assignments completed on time, which will typically be Sunday, 11:59 p.m., the day before we meet in class, get a bonus. And that way, as you go along, if you're turning in your assignments on time, you're racking up some bonuses. That's pretty cool. That's a cushion. So that if you don't get something done towards the end of the class, it's not a problem. You still may have a 100% homework grade. Plagiarized assignments. Plagiarized assignments, if I catch them, and I probably will, or at least I certainly have before, will be rejected. And you'll only get 1% credit will be awarded. And it's likely that I won't let you revise it. Although maybe I will. First time it happens, I might assume that you just didn't know what you were doing. And an example of plagiarism would be, say I asked you to write a sorting algorithm. And, say we were in a Java class, and I wanted you to write a quick sort algorithm in Java. And you typed in quick sort algorithm in Java, and golly, there sure are a lot of places where you can go and you can grab this code. Woohoo! Copy, paste, upload to D2L, fail. Because the reason why is I've read a lot of code and I will probably recognize stuff that you have created and techniques that we have learned in class versus stuff that you've copied off the internet. Does that mean that you can't take stuff that you learn off the internet? Does that mean it's bad to Google stuff up? No, it doesn't mean that at all. But you have to understand it. You have to make it your own. If you can't get something to work because you're getting syntax errors or the algorithm is behaving oddly, go ahead and Google. That's what professional programmers do. However, in most places you work, professional programmers are frowned upon if they just take big chunks of code that they found on the internet and paste it in their code. That can lead to legal problems, if nothing else. But here, I want you to be able to understand it. If I deleted your code and I asked you to rewrite it, you ought to be able to rewrite it in 15 minutes or whatever. You ought to be able to understand it that well. And if you copied it, wholesale off the internet, you're not going to understand it that well. That doesn't happen too often, but it occasionally happens. Who knows? Maybe it happens more than I know of. Maybe people are clever enough to trick me. But don't trick me. Learn the material. I'm here to help you. I will go to a lot of effort to help you. So, bonus for turning it in on time. However, after that, it's a 10% bonus for a week after that. After that, it's a 50% bonus. After that, yeah, sorry. You don't get more of a bonus the later it is. Woohoo, I'm going to turn in all my homework late. Get a huge bonus. No, sorry. 10% deduction for turning it in up to a week late. 50% past that. Don't do that. The reason there are deductions, a lot of instructors just say you have to turn it on time or, don't go. You don't get any credit for it. And in my opinion, I understand that life happens. You may have to fly out to Connecticut, and take care of your father's estate sale, or, somebody may be sick in your family and you really could not put in the time to work on it. I understand that. So, I don't stomp on you for turning it in a little bit late. But I want you to keep up, because if you're not keeping up, then you may be asking questions in class that everybody else already understands, which is okay. The thing is there's no stupid question. But it could get to the point where I'm saying, okay, we're going to need to talk about this after class. And more likely, if you're not doing the homework, you're not asking the questions in class either. And then you're falling way behind. And you skipped one assignment, and so you're probably going to be less likely to be able to do the next one, and it dominoes. So try to keep up with your homework. If you let me know why something is late, especially before it's due, don't come to me 2 weeks later and say, I was really having a hard time 2 weeks ago, and that's why I didn't turn it in. Let me know what's going on, and I might waive the penalties. You need to complete at least 50% of the programming assignments, and I guess I need to say that more often, because I get towards the end of the semester, and then I realize that some students have only done 3 out of 10 homework assignments. And this is a programming course. You're supposed to be applying your own knowledge. You could just read books and get okay grades on quizzes, and you could do the in-class assignments and have the guy next to you help correct your syntax errors and have me help correct syntax errors, and maybe make a C in the class because you've done enough credit, and not do any of the homework or just enough. No, I want you to be doing the homework. The homework is where you learn the most. You learn a lot from the in-class tutorials, but it's not until you apply it yourself in your own work that you actually, that it burns into your brain. And you're hopefully here not just to get something checked off on a transcript and a grade. Hopefully you're really here to learn. If you are, then the class is going to go really well. I try to be interesting enough that you want to learn, but I think, usually if people are willing to come in at night, they're here, because they want to learn. I want you to be here on exam days. Otherwise, and it's not mandatory for you to be here, but if you miss a week, it's kind of a drag. I try to video the screen and my voice, so that if you do miss a day, you can go back and listen to it, but that's not really as good as being here. It's just a backup, and it's possible that I could forget to do that, or that the file could get lost. So do not blow coming in to class. Don't blow it off just because oh, well, he's going to make a video of it anyways. Treat the video as a backup. The best thing for you to do is to come in here with a notebook, take occasional notes, type stuff in, and then watch the video again if you need some review.
Or if you get to turn on the mic.
Pardon me?
Or if you get to turn on the mic.
Yeah. The mic's on this time, but that has happened. And another time there was a horrible echo on it that made it so that it was impossible, to understand. And I see here that the speakers are on, and I hope we're not getting that horrible echo this time. If you don't show up the first week or two, you might get an AW, or you will. If you need extra attention or you need accommodations made for learning disabilities or physical disabilities, work with the Office of Disability Services. Call them up, ask for help. You know, accommodations might be, you might ask for me to record the things, which I do. You might ask for, extra time on exams, stuff like that. If you have a reading problem and things are more difficult to read, you can come by and I will explain them more carefully. Just let me know what you need. Academic dishonesty, we've already talked about that. Don't copy stuff en masse from the internet. Also, don't copy stuff from somebody else's assignment and then turn it in. In here, when we're doing in-class work, it's cool if y'all are helping each other, if y'all do a buddy system, because we can get through the assignments more quickly. If Matt's, done with his and he can look at your screen and help you, that's totally cool. In-class assignments, I expect for people sitting next to each other to help each other if you can. I mean, you don't have to, but if you can, it's cool. But on your homework, you need to be doing it, the vast majority of it, yourself. What I absolutely do not want you doing is taking your code, giving it to somebody else, and saying, okay, figure out what you're supposed to do based on this. Because what they might do is instead of taking your code and figuring it out and writing their own, they may turn in your code. And then the most egregious example of that is that one guy, the star student who had made 100 on every assignment and every exam, gave his code to a struggling student, saying, here, you can see how I did it. And that guy uploaded it to me as a finished assignment, didn't even bother to change the initials on the assignment. So I had, not only am I giving you a 0 on this because of academic dishonesty, but just for thinking I'm dumb. Like I'm not going to notice that the assignment is identical. Anyways, you get the idea. You need to make the homework your own. Talk to me about it if you're stuck. Some of y'all may have programmer spouses or, roommates or whatever. It's okay to get help from them, but make it your own. And I'd rather you ask me for help than them, but I understand that people, if you happen to live with somebody who knows the material, it's if they're willing to help you, I understand that might happen, but you need to learn it. They're not going to be there at your job doing it for you. Alrighty. So what we need to do is, I would like for y'all to go ahead and knock the intro quiz out because it's just a few questions. So log into D2L if you have not already. Go to our section. Yeah, I see 7 quizzes turned in already. There's a link to the quiz right here on the front page, or you can always go into Course Tools. Well, don't go to Content like I did. Go to Quizzes. There you'll see it. Just start the quiz. The first question is, have you had any programming courses? High school courses work? Go ahead and fill them in. If you haven't, that's okay. So as the professor, I must admit, I have no education whatsoever. No, I'm kidding. So then just scroll down to the next one. Do you have professional programming experience? It's totally cool to say no. Totally cool to say no, but I program all the time just for fun. Or, whatever. You're not going to get counted off. You're going to get full credit for whatever you type. And specifically, for question 3, I'm curious if you have any experience with Python or JavaScript. And that's probably answered in 1 or 2, but I'm calling it out as a separate question. And the reason for all this is I'm wanting to figure out how strong we are in the fundamentals. Because if you say you haven't taken any programming courses and you don't have any professional programming experiences, you don't have any experience with the particular languages we're using, then we're going to be stumbling a little bit. But if you have taken Intro to Programming, but you didn't use Python, that's okay. We'll make do no matter what. I don't. But it'd be useful to be able to gauge. And then the last one is please send me a text. So that should not take very long to do. You'll probably have to fill in something, or else it'll give you a warning. But about 12 students in here. I'd like to see, 10 of them done pretty quickly. So are there any questions about what we're going to be covering? Please go ahead and get the book. I'm not assigning book work for this upcoming week, but getting it as fast as possible is good for you. If you have taken my courses before, oh, you're not able to log in?
It's being very fast, as you can see.
You have the spinning wheel of patience.
No.
All right.
Did they?
Yeah.
I never used idle. I didn't like PyCharm.
Yeah, there's a couple different editors
It took way too long.
available for Python. One called PyCharm is pretty cool in as much as it tries to help you. There's a lot of editors for Java and for C++, as you type in and then you hit a dot or whatever, it'll list extra choices you can choose from keywords. And that's really cool, and PyCharm does a better job of that than idle. But idle is there by default. When you install Python on your home machine, you get idle as a matter of course. So I'm not expecting you to use anything else. I'll probably only open another editor just, for special effects. Not going to expect you to use it. All right, 7:40, in about 25 minutes I want to discuss the homework assignment, which is not terribly rigorous. Could talk about it now. Nah. So, what are our goals? This PowerPoint actually is for the version 1 of the text. The publisher hadn't okayed me to grab the PowerPoints for the second text, but they're very similar, I am sure, and by next week I am sure that I will have them. So we will learn about computers and programming. We will create, compile, and run your first Python program, unless you've had Python before, but like I said, we're not demanding that to be true. To recognize compile time and runtime errors, and to describe an algorithm with pseudocode. This sounds like stuff you may have learned before. It's maybe stuff that you haven't learned before. It's okay either way. So what is a scripting language? A scripting language is a programming language. Let's see if we can just get a good definition for the difference between a scripting language and a programming language, because really a scripting language is a programming language. Okay, how I would have said it is that a scripting language controls a specific program, whereas a programming language attempts to control your computer. That's not a real hard and fast definition, but like if you write a scripting language for a browser, like JavaScript, then what it does is it controls the browser. It controls what's displayed on the screen. Or if you have a database application like Access or Firefox, or I don't know what people use as database software for homes, that aren't using SQL or whatever. They would come with some kind of scripting language that allows you to make queries from the database, things like that. Now Python and Java and some of these languages kind of cross the boundary there, because with Java it looks like you're controlling the computer, but what you really are controlling is a program that's running on the computer called the Java Runtime Engine or the Java Virtual Machine. But it's close enough to controlling the computer that you think of it as being a programming language. Python also requires a program to run. You can see that program if you go to a command prompt, and if these computers are configured correctly, you type Python, and it opens a little window where you can type commands straight in, like print hello, and it prints hello. So we are telling this program called Python what to do. We are scripting it. So a programming language is typically compiled. You run it through a compiler, and that creates some machine language code that you can then run on that program, on that client. Whereas a scripting language is typically cross-platform, and it is interpreted, meaning that you have another program that reads that language as it's running. And that is true of Python. And then there are ones that, again, are hybrid languages like Java, where you write the code and it gets compiled, but it doesn't get compiled to machine language. It's nothing that'll run on an Intel CPU or whatever. It still requires another program to interpret that machine language. But that program can be written for both Mac and for Linux and Windows and whatever, and that makes it cross-platform. Whereas something like C++ is not really cross-platform. It's meant to be portable, but it's not cross-platform. You can't write a C++ program like, you know, a game or whatever and expect it to work on both Windows and Mac, you know, and your phone or whatever. You might be able to port it. Porting is what you call it when you take that code and you make necessary changes to get it to work on another platform. Interpreted languages have a much higher likelihood of being able to work without changes on multiple platforms, and Python is one of those. If you install Python for your Mac, or your Linux box probably already came with it pre-installed, then you're good to go. The same programs you write here, you can take home and run, and vice versa. That's worth me taking notes about, in my opinion, as something to write up, a little something I'd like for you to be able to. What is a scripting language versus a programming language? But ultimately, they are both ways of getting a computer to do something. A programming language is a series of statements that the computer sees and then follows. And programs are very literal. You know, computers are very literal. They do step by step exactly what you tell them to do. If you wanted to, you know, add 7 numbers together and then print the results, you give some commands that'll add those 7 numbers and print the results. And it's a series of instructions. So the anatomy of a computer. Do we really need to go over this stuff? We know what a CPU is. It's a little chip. We know what hard drives are. Those are those obsolete things that people used before they started getting solid state drives. Okay, so what is important to us? Wow, we've got the flickers back. I'd forgotten that we had those. Is the idea of input and output and storage. There are different ways you can interact with a program. So you can have graphical user interfaces where you're clicking on things, and that's generating what's known as an event, which triggers some code in that program to run. And then there are command line interfaces where you're typing stuff in and you see responses. You know, people call this DOS, but it's not really DOS anymore, although the syntax is similar to DOS of the old days. You know, everything that you type in here is a command. If you type netuse, you get a list of all the drives that this machine is currently attached to, or at least knows about. We see some network drives. And I could type in a drive letter, try to access it, and then the next time I typed netuse, it would show that drive as being active. So, you know, U is now listed as being okay, while the rest of them are disconnected, but hopefully still accessible. That is a command line program. And if I want to see additional things that it can do, I can ask it for additional help, and hopefully it'll list everything it can do. That's more of what we are going to be doing when we're doing Python, is command line. But there is some graphical user interfaces we can build with Python as well. So we will be hitting those as well. So that's input-output, is using your keyboard to interact with the program, and output is displayed on the screen. Or if you're writing a game, it may also be sending output to the speakers. If you're communicating with other programs on the internet, you may be doing some I/O with the internet. And this is a very low-level system thing that doesn't really influence us. We don't issue calls that directly control the network controller. But every programming book you buy has one of these things, you know, tries to teach you what a computer is. And they're always worth reading, but not necessarily worth lecturing about. So a program is a series of instructions. It may have been compiled into, you know, some other form of machine language, or it may be very readable. These Python programs are very readable. They look like English. So the programs are a series of instructions with accompanying data, like there may be sound files or pictures or, you know, something like that, that are stored where the computer can access it. On a disk, on the RAM of your phone, or on the internet, or something like that. And then when that program is launched, those instructions are brought into the execution of the CPU so that it can start following those instructions and perform the tasks. So it's like having a mechanism, a little robot that you're telling what you want it to do. It says the CPU runs the program one instruction at a time. Well, that's not strictly true. Nowadays you have these multi-core processors, Intel Core Duos and better. Our phones now come with like 4 processors, built in on a chip rather than just one. But typically we're writing sequential programs where one instruction gets executed after another. And if you become a programmer who is writing parallel processing programs, if you go on and to a 4-year college, you may get to do that, or if you learn it on your own or do it on the job, then that's a kind of a different skill, the ability to get the program to run on multiple processors. We're not going to do that. Python doesn't lend itself to doing that. We're expecting Python to run one statement after the other. And then as these instructions are read by the CPU, the computer reads the data, it reads the files, it modifies things as necessary and displays it on the screen or saves it back to storage. It does whatever it's supposed to do in order to add value to the process, whether it's a game that's supposed to entertain you or whether it's some kind of bookkeeping software, or you're analyzing data. So what you call it is the flow of information processing. It's typically some kind of loop. When the program starts, it may read some information, it may process some information, it may save that information. That reading information may be stuff that you type in, user input, it may be from a file, it may be from the internet, but typically it's either going to run once and then exit, or more often it's going to loop and repeat over and over and over, responding to your input. All right, the Python language, here's a little history of it. It was designed to be a simpler is not a good word for it, because it's an extraordinarily powerful language. But the syntax is designed to be simpler than things like C++ and all the languages that evolved from C++, like Java. But that doesn't mean that the stuff you learn in Python isn't applicable to those languages. But Python has such cool libraries that it comes with that you can often do a lot more with fewer lines of code in Python than you can do in a language like C++. And in those languages, they can do a lot more with a few lines of code than you could if you were having to write machine code, which is controlling the processor step by step. So 2 ways of creating software, typically. Use what's known as an IDE, an integrated development environment, or using a text editor. I can write a Python program just by typing in, Notepad, popping it up, typing in some commands, saving that program to disk, I'm not, and then executing that program from the command line. That's one way of doing it with a text editor. The other way is to use what's known as an integrated development environment, an IDE. And that's pretty much the industry standard for developing software. It's not a bad idea to know how to do it with a text editor, but you get a lot more done in a short amount of time if you use an IDE, and they're easier to debug. What an IDE is it's a program that lets you write and run programs. In this case, the IDE we're going to be using is called idle. So in the search box down here, you can type idle and hit enter. And we get this little command window here. My machine has been reset over the spring break, so all my fonts, everything's hard to see. An idle has 2 components. One is just the Python shell, which is just what we saw when I went to the command window and I typed in Python. but it also has the ability to create the scripts by typing in File New, and then I can type in some programs here. Now Python programs will work either way. You can type them in directly into the shell, or you can type them in as a script. The advantage of making them a script is that you can get the whole thing typed in, hundreds of lines of code, and then you can execute it all at once. Whereas if you're doing it in the shell, you're typing in one command, you're hitting return, you're watching it run something. And then you type in another command and you hit return and you watch it run something. And if you make a mistake, you have to type the whole sentence in over again. It's really much more convenient to write a script and then to run that script. So that's usually what we will be doing. There'll be times when I ask you to type it in directly into the shell, because you can certainly do that. Anything that the scripts can do, the shell can do too. Like I could ask for a value with an input statement. What I typed was A is equal to input, parentheses, quote, enter a number, end quote, end parentheses, and when I hit return, it'll say that, enter a number. Notice it did it right away. I wasn't writing a program, I issued a command, and it ran it immediately, and that's because I'm in the Python shell. But I could do the same thing with the script. Over here when I did File New Script, I could type that in. A is equal to input, enter a number, and it doesn't do anything when I hit enter. Why? Because it's creating a file. This file is a series of one or more commands that will run. And if I want it to run, I'll have to save it. I'm just going to save it to the desktop in a directory called scripting. So I click desktop, new folder, scripting. Go in here. I'm just going to call it T1. Now that I've saved it, I can run it. So I can choose Run Module from the Run menu. And then it will run and it'll do the same thing it did a minute ago from the shell. It'll say enter a number. So that's the difference between writing a script and executing a command. A script is a series of commands. The same commands that you can enter directly into the shell. But it's more convenient to enter it as a script rather than type it in and hope you get everything right in the command line, one by one. You type in 100 lines of code, you debug it, you can run it over and over until it's getting to work perfectly. So the source editor, what does the IDE do? It displays the code, and there are things it can do to try to help. It might have line numbers for the code. Now idle isn't that nice. It doesn't put line numbers down the side, but you do get to a line number down in the corner. Right there. And then when you run it, you can get an output window. There's my output. It'll do what's known as syntax highlighting, which is where different things in your coding are colored different colors in order to help you figure out what's going on. I'm going to type something I'm not expecting you to type. I'm doing this basically so you see the colors. I see something green here. That's text. I see some orange statements here. These are keywords. These purple are functions. Python comes with built-in functions, and then you can add your own functions. So the print statement is a function. It displays stuff on screen. Input is a function. It displays a message on screen and then stores a result back in what you specify there. Then there's something called a for loop. So this context-sensitive color highlighting makes it much easier to understand your code than if it was just black and white, or green on black, or whatever, if it was monochrome. So it's very useful, because what if I mistyped for? Now it's the wrong color, and if I'm used to seeing it in orange, I might spot immediately that that's wrong. Or what if I'm creating something and I try to store something in a variable called len? Well, len is a function. It's not a variable name, it's a function. And now that I've typed it, it's purple. Hopefully that'll remind me, oh, I better not overwrite that with a value. I better not do that. It wouldn't give me a syntax error if I did that. This language is kind of odd in that case. But the color highlighting is to give you additional information. The more information you have, the better. And at first, it doesn't all sink in, you don't have as many channels open. But the color is one of the channels, that the information is being presented to you. Another important channel is just the way the code looks. With indentation, you can see the structure of the code. Some programming languages let you indent code, but it's not required. Python makes you indent the code. It will not work if it is not indented properly. Like if I remove that one, then my little print statement is no longer going to work. I'll get a syntax error. My syntax error is expected an indented block. If you've done other programming languages, you may be used to seeing braces. I sure wish Python had braces, but they don't work. If I tried to run that, I'd get an error. And the basic programming language, has begin and end statements. Well, Python doesn't do that. It's all based on indentation. So, indentation levels are another channel of communication to you about the structure of the program and if it's well written, but Python enforces that to be done, whereas in other languages, you can be sloppy and you might not indent things correctly. The editor tries to help by auto-indenting. Now that I have this file open that I did by file new, if I type if a equals 3, I don't need to put quotes there. I'm typing in another language when I do that. And then I put my colon. The colon is the way that you start an indented block in Python. So it indents it. And then when I'm done indenting, I hit the backspace to delete that tab, and then everything I type in is going to be unindented. And then if I type another colon, it's going to start indenting again. Now this syntax is obviously absolute garbage, but it's trying to help. It's keeping the level of indentation for you. Once you do one indentation, it stays at that level until you backspace and erase it. Once you type a colon, it auto-indents the next line. So it tries to help you. But indenting is one of the quirks of Python that will annoy you at first, is getting that right. Okay, so if y'all want to play along with what I typed here, I'm going to make the text larger so that you could type it in. So if you have not already done so, do File, New File, and then save it to your desktop, hopefully in a scripting folder, or save it to a flash drive if you're going to be storing your work on a flash drive. And by the way, that's really not a bad idea at all, because you never know when one of these machines will die and be carted away, and then you lose everything that you thought you had. So it's a really good idea to save your work to a drive that you bring to class, as well as doing it on the machines here. Okay, so I'm going to wander around and make sure that everybody gets this running. I know it's basic if you've had Python before. When you're ready to run it, do a file save as, and as I mentioned, save it to the desktop. It's expecting the extension .py, but if you don't put an extension, then it adds it. So I just typed T1, hit enter, and it saved it as T1.py.
This,
Yeah. if you haven't made any syntax errors, it'll print enter a number, it'll wait for you to type in something, and then it'll print the numbers 1 through 9. You may think it's quirky that it goes 1 through 9 when we see the numbers 1 and 10 here, but we'll address that at a later point. Now this doesn't do anything with that input. We type in something and we store it in a place in memory, but we never do anything with it. So, you know, it's useless. You don't have to just type in a number. You can type in anything there that you want. All right, anybody getting syntax errors? Don't correct me.
Yeah, because we did this last
So
semester.
if you notice, what's going on is we have something called a for loop, which repeats over and over. How does the program know what code is in the for loop and which code isn't? By its indentation level. Everything that's indented under the for loop is considered part of the for loop, the code block that's under the for loop. And it will get repeated over and over as long as it's looping. And this unindented code is not part of the for loop, so it will only happen when that looping is done. And that's why it prints those numbers, and then we get that done message. Alrighty. Once you get that working, that's great. I think I'll make a Dropbox so that you could upload that file, get some credit for it since we did some work in here. Then I'm going to talk about the homework that I would like for you all to do this week. So although there's no instructions or whatever tagged along with it, if you go to the Dropbox, you'll see a homework, and that's what I want you to work on this week, and then you'll see something called In Class A. For this class, I'm going to be numbering the homework assignments, but using letters to refer to the in-class assignments so they're easy to distinguish. If you miss a week, just watch the video and work along with the in-class assignment. Hopefully the video has audio and everything, you know, so that you can do that. All right. So to submit a file, I know everybody knows how to do this, but I'll work through it anyways. You go to that Dropbox, you click on the Dropbox name to enter it. So I'm clicking on In Class A. And then I need to add a file to upload. And these Python scripts are so small, and right now we're only turning in one file at a time. You don't need to zip them. So you just click Add File. You go to your desktop or wherever you save that Python script, and you upload that. I put mine in a folder called Scripts, so I need to find that. Choose my file and upload it. Now doing that upload doesn't actually submit it. It's like attaching an email attachment. Just because you attached a picture to your email, until you click the send button, the receiver's not going to get it. Well, until you click submit, it doesn't go into D2L. Once you click submit, then it'll say confirmation email sent, and you'll get emailed at your school email account saying that it was uploaded. If you do not put an extension on your file for some reason, which is more common on a Mac than on a PC, then D2L will not accept it. All right, so the homework. There's two things that I want you to do. One is I want you to either install Python or decide that you're going to do all your homework here. And I'd recommend you install it at home if you have a computer at home that, you know, it doesn't have to be super duper powerful. Python is not a giant, you know, if you can run, you know, Facebook and Twitter and stuff like that on your computer, you can run Python on it. So you're going to go to python.org. to Downloads, and you can pick the one you want. I want you to download the 3 version rather than the 2 version. We're going to be using 3.5. Or
Last time.
tell me, I think we were using 3.4 something.
Yeah.
Yeah. Let's go to the Dropbox as I talk through this. That's the first part, is I would like for y'all to install that. Whoops, I opened the in-class assignment. So this assignment is just going to be filling in stuff to upload. Fill in your name. My name is Joe. And then tell me that you've installed Python 3, or if you're instead doing all your homework on the school computers, please say so. Say, I am installing Python on everything, even my toaster. Then page 2 is where there's actually some homework to go along with it. Now, it doesn't use Python that you've installed. You can do this one at home on anything with a browser, including an iPad or an Android phone or whatever. But of course, it's a lot easier to do if you're doing it on a PC with a keyboard and a mouse. And it's a site called codeacademy.com. And if you've taken 1113 with me, you've used codeacademy.com and you did this same stuff that I'm asking you to do again. Well, register with a different email address so that it wipes it out. And just repeat the assignment. It'll only take you 20 or 30 minutes if you've done it before. If you haven't done it before, it's going to be very valuable for you. If you have done it before, it's going to at least burn in, brain cells that may have switched off over the Christmas break or whatever. So I want you to do 2 things. There's a lesson called Python syntax. And then there's another one called strings and console output. Just try to work through those. If it turns out that half the class doesn't get it done, in a week, then I'll extend the deadline or whatever. But try to work through them. And if you get stuck, let me know. Like I said, you can take a picture and text it to me or whatever. I can help you with it. And what codeacademy.com looks like once you register for it is it's a tutorial where you type stuff in and you work through it. Okay, I'm going to log in with Facebook, if it'll let me. So once you come back in to Python after you've logged in, just go to the main page of Python. You can always click on that thing and it'll go to the main page. And then scroll down until you see Python, or do a Control F or whatever. There he is. And do that first lesson, or you can just follow the links that are in the Word document. And it gives you some help. It says, ready to learn Python? Click Save and Submit to continue. Okay, so I do that. I click Save and Submit, and it's going to execute that statement. Now, this tutorial is written for Python 2. That's not going to make much difference to us, except that in Python 3 in class, you have to put parentheses around your print statements, whereas in Python 2, you don't. So these examples here are not going to show parentheses after print statements. But get used to putting the parentheses there. It'll work either way in this tutorial, but when you come to class, you have to have them. And the book also shows them. So you're going to see more stuff with the parentheses than not. But their code samples will not. And, it works either way for this. So then it says, way to go, start next lesson. And then it says, instructions, set this variable equal to the value 10. So I would have to come in. I've already done it. That's why it's there. I would type in 10, click Save and Submit. Now I've finished that second lesson. I go to the third one, and so on. So you follow the instructions. You read the stuff here. You follow these instructions. You look at your code. You make changes according to these instructions. When you're ready to run it, you click Save and Submit. If there's some kind of syntax error, or you do something wrong. Okay, there's a syntax error. So when I click Save and Submit, it gives me some error messages. You have to kind of just get used to reading error messages. It says true or false is not defined, and you go, yeah, I don't remember typing true or false. So you come over here and okay, I see my problem. And we look at the instructions again, and that word is supposed to be true. Okay, cool. So I would change that to true. If I got stuck, there's a hint button. I click hints and it says remember to capitalize true. And that is in fact, no pun intended, true, because in a lot of languages true is not uppercased, and this one it is. So I make those fixes to it, I click submit, way to go, I click next lesson. So that's what it does, and it really doesn't take too long to go through it. But it shows you the basic syntax that we will be learning about. You know, it shows creating variables and using equal signs and storing values in variables. So it's basic syntax. And it's a good little review if you've had the language before, and it's invaluable if you have not. So go ahead and work on that and try to get as much of it done. As you keep hitting save and next and save and next, it'll eventually award you a badge for having done the syntax section, Python syntax. And then there's another section I would like for you to work on as well, which is strings. Strings and console output, which is more about how to print and how to save string data. And what is string data? It's just, you know, a series of letters, you know, like your name or whatever. So see if you can get that done. Those are the two things that I would like for y'all to work on this week. And if you've already done these, like I said, I would like for you to do them again. Just to burn it in, just so that, you know, next week you still remember everything that you learned last semester or the last time you took Python. And if you haven't, then you're learning a lot. Also, once you get your book, just start looking in it. Look at Chapter 1. Chapter 1 is almost our review, so we're not going to spend a lot of time on it. And then we're going to very quickly, as of next week, go to the next chapter. But it does have useful information. Your first program. Python functions, what are they? What is an error? You know, it's got some stuff that we will be going through. Alrighty, that's about it. We've used up our time, I believe. I will upload this video that I made into a videos directory in the content section. So if you weren't here today, that's a joke. So if you want to, you know, review anything that we talked about today, you can do so.